Right there, ladies and gents. Let's check, or let's just talk a little bit about the proof we just wrote. And so this is definitely a step up from the proofs you've been writing in the past. But in the end, like what this really is a formal argument. A lot of people, when they take geometry, think that writing a proof, writing an argument might be the toughest thing. And that's, I don't think, it's really the case. As long as you have a really solid structure like we have, you backed up by facts that you know, like we've taken some notes over, then this is really kind of a straightforward exercise. Now, I do want you to follow the same structure that we did before. But let's just get into it. Let's talk about how to prove ABCD is or comma is not a rhombus. But the first step is still forming a personal belief. This is a really important step in the proofwriting process because it not just connects you to the information, but it also kind of proves that you kind of evaluate the picture at least very casually. So the first thing we're going to do is just look at ABCD and ask ourselves, well, does this look like a rhombus? Well, you still have to have the definition in mind. The definition in this case is that a rhombus is a four-sided shape, a quadrilateral with all the sides the same. And so I'm just kind of looking at ABCD and I'm asking myself that question: do all the sides look the same? And then respond just with an opinion. So I think yes, ABCD is a rhombus. And I'm gonna offer because here, and the because is all the sides look the same. All right. Now, again, that doesn't have to be based on anything in particular. It just has to express your opinion, but that opinion should be backed up at least colloquially with like just a little bit of fact here. And the fact of the matter the definition of rhombus is all the sides have to be congruent, and it does seem that way, at least to the eye. So now we actually have to move into forming a plan. Now this is a formal part of writing proof. We're not going to do anything here. We're just going to identify what we should do, and honestly, a couple sentences should be more than enough. And so if the definition of a rhombus is that all the sides are congruent, the question you need to ask yourself, I need to ask myself, well, is how do you show all the sides are congruent? Congruent is length, and so length means I got to do some calculations. If you double check your notes, length calculations are either Pythagorean theorem or distance formula, and so that's why I have to record here. And so again, two sentences may be enough here. I don't want to cramp your style. You can use many as you want, but I think efficiently two should be enough. And so let's start it out like this. So to prove ABCD is a rhombus, I have to prove, or I have to show, and I'm going to write this kind of an unusual way. I have to show that AB is equal to BC is equal to CD is equal to AD. In other words, all the sides are equal. And so let's start with a new sentence. To do this, I will use, in this case, the Pythagorean theorem. We're also going to use a little bit of counting. Okay, so I lied there. I think I said two sentences. I think three sentences probably be good here. The last sentence should always be like an if-then statement. And so if all the lengths are the same, uh, then ABCD is a rhombus. Okay, and both parts of this are true, I'm sorry, necessary. So the two parts being like I have to identify what I'm going to do. So I identified that I have to show all the sides the same. I'll use Pythagorean counting to do it, and then I gave myself like a success indicator. If all the lengths are the same, then ABCD is a rhombus. Okay, and so the last part of this is going to be to actually do it. And I have to record my work in step 3, but I can do the work up here on my graph a little bit. So identify I'm going to do two things. I'm going to do some counting, and then I'm also going to use Pythagorean theorem. So let's count first. So I'm just going to look at AB. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so just by counting, I know this length is 10. I can do the same thing for the bottom. If I count across the bottom, this is also 10. That was the easy part, but I said I would do that. Now the second part is I'm going to use Pythagorean theorem. To use Pythagorean theorem, I need right triangles, and so I'll create a couple right here. So the triangle on the right, the top part is 1, 2, 3, 4, 5, 6. Part along the side is 1, 2, 3, 4, 5, 6, 7, 8. And then I'll make another triangle on the left-hand side, and then counting, looks like again we have 6 and 8. And so I still have to run the calculations to see if they're 10, but at least now I have the numbers to do it. And so I'm going to do the mathematical work down here. So for AB, it was easy. That's just 10. Again, I just counted that along the top. DC, I'm also going to count. That's just the bottom. The ones I actually have to worry about are going to be the AD, the left-hand slanted side, and the BC, excuse me, the right-hand slanted side. Now for AD, I said I was going to use Pythagorean theorem, and so let's do that. So A squared plus B squared equals C squared. Filling in the pieces, I have 6 and 8. So that'll be 6 squared plus 8 squared is equal to C squared. Now I'm going to have to run some mathematics here, but that's okay. 6 squared is 36. 8 squared is 64. And that's equal to C squared. 36 plus 64 is 100. Okay. Then of course if I now square root both sides, we have this being equal to 10. And so I have these three parts equal to 10, but I still got to run the last part, the last bit of it over here, this BC. But if you look, I'm substituting the same exact numbers I did in the previous part, and so we can probably speed this up a little bit because we can reasonably assume, yeah, this is going to be the same now. So again, we have A squared plus B squared is equal to C squared. Again, we're going to have 6 squared plus 8 squared is equal to C squared. Okay, and so just like before, it'll be 100 to make C squared. Square root both sides, and we have C equaling 10. And so we said in a previous step that all the pieces, we're going to use Pythagorean theorem of counting, and then if all the lengths turn out to be the same, then we can conclude this is a rhombus. So we did that. We counted at least two parts, the top and bottom. They were 10. We calculated the other two parts. They're also 10. And so now we can write our conclusion. And the conclusion has got to be based on step 2 and 3. This has nothing to do with your opinion. The conclusion is all about what you actually know. And so I'll start this out with a because. I know we all love starting sentences with because. Okay, so because AB was the same as BC, was the same as CD, was the same as AD, all the sides are congruent. So ABCD is a rhombus. Okay, so that's the entire proof. And so again, this is a very formal argument, maybe overly formal for this application, but nevertheless, this is what you guys need to learn right now. And so we had a personal belief that this was a rhombus because the definition said all the sides are congruent, and those look it. We made a formal plan, what we're going to do. So we know to prove a rhombus because of definition, you have to show all the sides are the same. We're going to use a Pythagorean theorem and counting to do it. If all the lengths are the same, then this guy's a rhombus. And so that's what we're going to commit to doing objectively. So down here, we did a mix of counting and a little bit of Pythagorean theorem. We use the grid up here to help us do that, counting the parts we need, marking out the parts we couldn't just count. All the lengths did turn out to be 10, and so a reasonable conclusion is that because all the lengths are the same, all the sides are congruent, so A, B, C, D has to be a rhombus. And guys, that's really all there is to it. So if you can do that, you're ready for the rest of the homework. So we're going to So at this point, come up and go and grab the rest of the homework if you're feeling comfortable. That's where you need to prepare. Okay, so there is going to be, in addition to this, a quiz. So please make sure you're prepared to take that quiz. All right. So practice these proofs. That's what's going to be on the quiz, of course. And that's it. That's what I got for you. Thank you.